All right, so when we talk about parabolas, we're going to be given three different types of equations, just the forms are going to be a little bit different, and what we're working with today is the standard form. All right, y equals ax squared plus bx plus c. That's your standard form. Now the trick to doing these is understanding these five steps, and you probably will want to do a lot of reviewing. As you're looking at the homework tonight, you're going to want to have your notes out. All right. I'm going to post the voice recording on Moodle. You might even want to listen through it again as you get stuck to just kind of review. I am recording myself, yes. All right, I think there's recordings for the other ones already on there, but I didn't have the recording for this one. All right, so you want to think about a parabola. It's going to be similar in the way we look at it to an absolute value function. All right, we know if it opens up, we're looking at a sign, and the sign in this case that determines if it opens up or down is the sign of the a. So it's the sign in front of the x squared term. So the first thing I always want you to tell me is the direction. It's kind of like a little self-check. If you know it opens up, but you open it down, that means you've done something wrong. Okay. We have minimum values and maximum values. So clearly, if it opens up, your vertex is the minimum value. It's the lowest value. And if it opens down, then your vertex is the highest value, or the max. Now, when we talk about mins and maxes, we're looking at the y value of the vertex. All right, so part 2 is figuring out your y-intercept. The y-intercept is where the graph crosses the y-axis. So the x value is going to be 0. Well, if we look in standard form, if x is 0, this term drops out, this term will drop out, and that leaves just c to be your y-intercept. Does that make sense? And when it's written in standard form, c is your y-intercept, yes. All right, and then what we do is we come up with the equation. We need to figure out our lowest or highest point, which is the vertex. And so we start with the fact that there is this relationship for x that is negative b over 2a, and you're just going to have to memorize this. You need to know that. So I really do suggest that maybe for this chapter you have some kind of a formula sheet going on, so that you've got it constantly to refer to, so you know what you're looking for. And all these 5 steps are the first thing that you're going to want to put on that formula sheet. All right, axis of symmetry. So a parabola is symmetrical. If my hands are my parabola, my body is my axis of symmetry. I can fold the parabola in on itself on my body, and one curve will fold right onto the other. Okay? When we talk about an axis of symmetry, we are talking about the fact that we're creating a line. It's a vertical line. And so if it's vertical, that means it's an x equals line. Right? Horizontal is y equals. A vertical is x equals. All right, and then because the parabola is symmetrical, every point on the right side of the curve can get reflected over the axis of symmetry to another point on the left side of the curve. Okay, so we have a parabola that points up. We have our vertex. We have an axis of symmetry that's going to go through that vertex. We have a y-intercept that is a certain distance from our axis of symmetry, which I'm going to call D. And we can reflect that point across the axis, that same distance, to come up with another point that falls on the opposite side of that curve. Does that make sense? Okay, questions? Well, no, D is my distance. It's the distance from my y-intercept or from a point to my axis of symmetry, and that same distance is going to occur then on the other side because it's going to get reflected. All right, so here we go. The first equation is y equals negative 4x squared plus 8x minus 3. So let's go ahead and define. What is a equal to? Negative 4. What is the value of b? and C is -3. All right, so we're going to just follow these steps. Number 1 is the direction. So we look at A. If A is -4, how does this open? Does this open up or down? Down, good. Because it's negative, that means it opens down. All right, step 2. We said find the y-intercept. The y-intercept is when x is 0, so y is going to equal -4 times 0 plus 8 times 0 minus 3. Well, these drop out, and so y equals -3, so our point is 0, -3. Well, that's how we define the y-intercept. Yes. Generally, yes. Okay. All right, step 3, we're trying to find our vertex. In our vertex, we said x is going to equal -b over 2a. That's how we define the value of x. All right, so that means the opposite of what did we say b was? 8 divided by twice a, and a we defined up here to be -4. So this is -8 over -8, which is +1. So that's what x is equal to, yes? But I want a point, and to have a point, I need an x and a y value. So all I have is part of my x, or part of my point. I just have the x. How am I going to figure out its corresponding y? Where would I put or find that y value? Jeanette? Yes, I'm going to substitute. I know that y equals, this is my equation. This is where I'm going to figure out its corresponding y value. So I want to see you plugging it in. All right, y is equal to -4 parentheses 1 squared plus 8 parentheses 1 minus 3. So that's -4 plus 8, 4 minus 3, so 1. So the vertex has a value of x value of 1 and a y value of 1. All I did was plug it into my equation. So far, so good? All right, at this point, we're going to start plotting what we have. And so the first thing that I want you to plot is your vertex. And I want you to use a red pen for this. I want you to differentiate this point from your other points. The problem is going to be at this point is when you get too many points, you're going to start wanting to open it in the wrong direction. So as long as you know where your vertex is, you'll open it up correctly, assuming you did the math right. So our vertex is at 1, 1. That's the only point that should be a different color. That should be red or green or whatever you want. After that, let everything else be black. All right, what is the other point that I have that I can plot? The y-intercept, right? What's the y-intercept? 0, 3. 0, -3. 1, 2, 3. There's my y-intercept. So I know it's opening down, which means I'm going to be drawing it going down like this, correct? And this is why I'm showing you very often, if you don't determine the difference, can't you see that you might want to go up? Right? So if you know where your vertex is, you'll know that from there you're connecting the next point. All right? Okay, step 4 is my axis of symmetry, and we said that's always an x value. It has to go through the vertex. Let's draw it. There's my axis of symmetry. It's got to be on your picture. And what is that equation? X equals what? 1, right? It's going through the x value of 1. So x equals 1 is the equation of that dotted line. All right, currently what I have is a parabola that looks like this. It's curved, not pointed. Okay, this is my x-axis and my y. All right, now, here is my point. This is the one that's going to get reflected to the other side, right? Y'all with me? What is the distance from this point to the axis of symmetry? How many units? 1. So from here, how many units do I go to the right of that axis of symmetry to get the reflected point? That means it goes right here, yes? What is the coordinate of that point? What is it? 2, comma, -3. Finish your drawing, and you're done. Amber. Well, this is a vertical line. A vertical line is an x equation, right? It's going through this point. Oh, look, it's going right there. It's hitting the x-axis at 1. Yep. Teresa? Yes, because it has to go through the vertex. Yes, exactly. Good. Okay. All right. So let's go through the steps again. Number 1, we tell the direction. Number 2, we find the y-intercept. 3, we find the x value of our vertex and plug that value into our equation to figure out our corresponding y value. We graph the vertex. We graph our y-intercept. We know that our axis of symmetry goes through our vertex and it's an x equals value. We reflect our y-intercept on the other side, and then we write that point down in step 5. That make sense? All right, let's look at example 2. What do you see immediately as a difference between example 1 and example 2? Okay, f of x versus y, that just means there's another way of writing y, but more specifically, there is no b. So b is going to equal 0. So we can think about that as f of x, or y, is equal to 1/4 x squared plus 0x plus 2. If you want to keep writing it in standard form so that it looks a little bit more simpler, or what you're more familiar with. Okay. All right, so let's start with our steps. Number 1, what's number 1 step asking of me? Okay, directions. So how does this open? Okay, we're looking at 1/4, which is positive, so it opens up. Step 2. What does step 2 ask of me? Okay, plug in 0 to figure out your y-intercept. So y is going to equal 1/4 0 squared plus 2, which is 2. So 0, 2 is your y-intercept. So far, so good? It's very step-oriented. Okay? What's step 3 asking of me? The vertex, okay? What equals negative b over 2a? Okay? X equals negative b over 2a. But what did we say b was? 0 over twice 1/4, where 0 over anything is what? Okay? So if x is 0, how do I find y? Okay, I substitute. So y is equal to, oopsie, y will equal, what is it? 1/4 times 0 squared plus 2, so we get 0, 2. Okay, why is there a problem at this point? Yeah. My y-intercept is the same as my vertex in this case. Was it the same in the other problem? No. In the other problem, I had a distinct y-intercept and a distinct vertex. Do you see that? All right, so that means I got a problem. Because as I go to plug this in, and I plug in 0, 2, I'm going to mark it in red because it's my vertex. I don't have another point that I can plot and then reflect, right? Okay. However, I do know that where is my axis of symmetry supposed to go through? That value, right? So I'm going to go ahead and draw it. And I need to know then that the axis of symmetry is x equals what? What is the x value that that dotted line is going through? 0. Yeah, it's just going through 0. So that's the equation of that dotted line. Does that make sense? Aren't you glad you're not missing this lesson? Okay, for all those people that are on the field trip. Okay, so here is a problem. I need a point, and I have to reflect that point. So when there's no B, I have a little more work that I need to do. How do I find a point? Sarah, pick an X, any X. Pick a number, any number. 2. Let's let X equal 2. Okay, this is my step. If I let X be 2, I need to figure out its corresponding Y value. How do I figure out that corresponding Y value? Plug it back into the equation, right? Does that make sense? Every X value is going to fall on the curve. What defines the curve? The equation that I gave you up above. So I can pick any X value. Keep it small because it's quadratic and it'll be squared. Okay? So if X is 2, then Y is going to equal 1/4 times 2 squared plus 2, which is going to be, it's 3. All right. So the point that I have is 2, 1, 2, 3. All right, let's check ourselves. How is that supposed to open? Is this going to open up, or is this opening down? It opens up. From the red dot to the black means it's opening up. So I know I must have done something right. Because remember, the red dot is your vertex. That's where the curve changes direction. All right. So I have a point. How do I find its reflection? Count over from what? Okay, I'm going to count how many units? There's 2 units this point, so then guess what I get to do? 2 on the other side. If I go 2 on the other side, then I need 2. Yep. So I'm going to be right here. So it's at -2, +3. Remember, it's a reflection. Your axis of symmetry happens to be the y-axis. So if I go 2 units to the right, guess how many units I have to go to the left? 2. Yeah, you have to give me the 2 points. Well, you had to give me 2, 3, and then you have to show me that -2, 3 is also a value. Just do a little chart like I did. Okay. Questions? Because this is the one that I solved for when X was 2, right, Annie? And that's 2 units away from my axis of symmetry. So I got to go 2 units to the left to reflect it. So if I go 2 units to the left, that leaves me at -2, +3. All right, let's look at the next one. Oh, and let's talk about maxes and mins. Sorry. Do I have a max or a min at this problem? A max. What is the maximum value? It's the y value. The maximum value is your y value. Okay? How about this one? Max or min? Minimum, right? I have a minimum value. I'll never have a maximum because I've got arrows, so they go up forever. But I have a low point. There's a lowest point. What is my minimum value? Yeah, it's the y value of your vertex. Do I need to graph it to be able to find my max or min, or do I just need to find the vertex? Just find the vertex. Okay? Okay, here we go. Y equals 2x squared plus 6x plus 3. Tell me, is this like problem example 1 or example 2? I have a B, right, okay? So it's like example 1. It is helpful for you to look for patterns so that you're doing them in the right way. There's only so many ways I can write a parabola. So you've got to be able to compartmentalize in this chapter. Which one is this like? This is like example 1 because I have a B. All right? This is like example 1. Okay, so step 1, what does step 1 ask? And how does this open? Okay, what does step 2 ask me? All right, that's when x is 0. If x is 0, what is y? Right? It's this value right here. All right, what's step 3 ask? Vertex. Look back at your notes. That means x is equal to negative b over 2a, which is negative 6 over twice 2, negative 6 over 4, negative 3 halves. All right, you're going to have fractions and you're going to have decimals, and you have to start getting comfortable with that this year. Well, negative 3 halves is what kind of a decimal? All right, so if you don't like that, write it as x equals negative 1.5. Okay? I have to find my y, and we know that we substitute. So show me y is equal to 2, parentheses, negative 1.5, close the parentheses, stick that square on the outside. If you are sloppy about your parentheses and your squares, you will consistently get these problems wrong. You've got to substitute correctly. Plus 6, parentheses, negative 1.5, close parentheses, plus 3. Okay, get your calculator out and do it. Half of you will get it right, and half of you will get it wrong because you're not plugging them in. So plug it in. You don't have to do it in steps. You just have to stick it into your calculator just as it's written up there. Some people get negative 9. The answer you should get is negative 1.5. So the vertex is negative 1.5 for the x and negative 1.5 for the y. Agreed? Okay. Now we start graphing. Remember, around this step is where we start graphing. So we get our red pen out. Negative 1.5, down 1.5. Well, that just puts me right here in this block. Right in the center. And our y-intercept was at 0, 3, so we're going to put that back in black. That's right here. And this opens up. Well, that's straight. Hold on, let's see if I can curve it. So it looks a little like this. And step 4 is our axis of symmetry. What is our axis of symmetry? Huh? What's negative 1.5? X equals. And so we're going to put our little dotted line. Now, what is the distance from your point, your y-intercept, to your axis of symmetry? How many units have you traveled? 1.5, right? That's 1.5 units. That means I have to travel 1.5 units on the other side, yes? So 1.5 and 1.5 is what? It's 1.5 plus 1.5. Negative 3. So what is our reflection point? Negative 3, 3. How'd we do? A lot of steps? All right, here we go. You don't have this, but I want you to work these next two problems out. If I can get it to turn. Here we go. I want you to pair up with 2 or 3 other people. All right? You need to be working and talking to someone about these because there's a lot of places where you or your friend will get stuck, and it is to your advantage to help each other out before I set you loose on your homework. So scoot your desks. Scoot your desks. I want everybody working with somebody.